So this is a demonstration of my brand new antenna tracker based off the Eagle Tree systems. I'm using the vector control system on my tricopter for signal source, and I'm using the ground station. And you can see I've also got the power panel, not a requirement, but I've got the ground station auxiliary option in that as well. Using the immersion RC receiver with a Ivy Crazy 5-turn helical antennas. Good evening. It sure is. So I'll walk through with what I found to be how the system works. I see a lot of people using these things, and as a newbie had no idea what it took to get these things to work. And when I went through the stuff online, I had no idea what it took to make these things work and how much stuff I'd need, and sometimes it looked like there wasn't enough parts involved. So you'd see antenna tracker, and I'd have this little printed circuit board. It's like, well, that can't be enough. So here's what I found, how these systems work. Again, I'm using the Eagle Tree systems, so other systems are out there. May vary a little bit. But here's essentially what you got to have on the aircraft. You need to have GPS data. So Vector has the GPS unit right there. So the aircraft needs to know where it's at. Second off, you need to take that GPS data of the aircraft and you need to transmit it back. So that's usually piped in onto an OSD system, which I have the vector controller, also does on-screen display. So it takes the GPS data, superimposes it into the on-screen display, and also embeds it into, I don't know if it's in a sync signal or the audio signal, but there's actual data, a data stream that gets embedded into the on-screen video source, whether it be the video synchronization signals or the audio. And then of course you need to have a transmitter to transmit it back home. So that's what I have here, GPS data. Gets mixed in with a video source and then gets transmitted back. So now we know where the aircraft is at. And of course, well, at least it's sending the data. Next thing you have to do is you need to have, obviously, a receiver on the other end for that. And I'm using 5.8 gigahertz. And I'm using a diversity system here, so whether the signal comes in from a directional antenna, if that doesn't do real good, I still have the omni-directional as a fallback. And as you can see, this thing here is chattering all kinds of crazy here, because it's not getting a really good clean signal from either one of them. Can't make up its mind. So anyhow, so you get the video signal back in. That video signal, the video and the audio and synchronization obviously comes back into this ground-based station. Now the ground-based station then takes that data, processes it, and outputs it through two servo motors here. One runs the pan direction and one runs the tilt direction. But in order for that data to mean anything, the ground station needs to know where it is at. It also needs to know where it's pointing. So there's a 0 position you've got to set up, and you've got to tell the unit where 0 is, and you've got a couple different ways of doing that here. First off, on the Eagle Tree systems, and I don't know that I agree with how they're doing it, but it works. The vector system, when it boots up, is going to be learned where it's at, and it's going to store that in a parameter called home. That home position is what Eagle Tree ground-based station uses as its reference for where it is going to use as home. The vector system, if you boot up into that, and you can optionally move the aircraft around to other places, and at any point in time you go into the menu and you can reset and tell it that's home. Well, so my problem with that is that I'd like to use a return to home. Well, return to home I'd like to have out in the field somewhere, but if I tell it out in the field somewhere, the ground-based station is going to know that that's home, and when you get in close, it's not going to be pointing back at the ground-based station. So home, though, in this system is where the ground-based station is. Next thing the ground-based station needs to know is it needs to know where its mechanical 0 point is pointing at. So that's going to be called its pan 0, the 0 degrees. It's going to rotate 180 degrees plus to the right, 180 degrees to the left, and it needs to know where the 0 point is pointing at. Now you got a couple different ways you can do that in this system. You could set it up, point it. You could use a compass, and you can go into the menu system and you can program the compass heading of 0 is where you have a mechanical point by way of compass. Another option is on this unit I have a magnetic compass already built into this system, so I can also go into the menu system and program it that the compass of the aircraft is 0. And another option is to take the aircraft, bring it a fair distance away from your ground base station in the direction of 0, and then tell the difference between home and the current aircraft position is your 0 direction. So a couple different menu choices in there. Once that's programmed in, then the base station knows not only where home is, but then it also knows where 0 on the mechanics are, and then from there on, certainly the pan is just going to be, horizon is at 0 degrees, and 90 degrees is going to be pointing straight up. So let's go into the menu and see what I have here. So going into the menu system of the vector, scroll down to the Eagle Tree station settings there, and as you can see right there, I can just set a compass point, and I can scroll that up and down. If I know it's pointing south, I could just dial that into 180 degrees, and we should be pretty close. But that's bring along on a compass. So that's one option. So either 180 degrees. It's been told that that's from my 0 position. I'm pointing due south. Okay. Another one is, say I'm going to use the present compass of the aircraft as my 0. So we'll just go see how close I was according to the aircraft. Well, look at that, 180th. The aircraft says it's pointing at 172. And then we'll go into the other option and we'll go move the aircraft. So now I've moved my aircraft. Yeah, I don't think I did very good there. Well, in the general direction of straight in line with my mechanical 0 position. We go back into the menu screen here.
Self-level off.
And we'll say the model location is my 0. And there it says it's at 200 degrees. So that's the difference between the home position and the current location. So those are the 3 options I have for setting where the 0 tracking is. And if I come back up here and take a peek, the antenna tracker isn't too terribly far off. I'm going to be probably happier with that positioning. and with luck, with some little bit of accuracy, it's pointing at the aircraft. So there we are. We're tracking it by way of GPS coordinates. Home position is the ground station, and the current location being transmitted is the aircraft position, and it knows the ground station's 0-degree pointing, and that should follow the aircraft at this point. And the GPS is not terribly consistent, so it's plus or minus. At great distances it'll be plenty close. As you get close, it's going to have a tough time, but you notice we've got a little bit of distance here, and it's using the directional antenna. That's the strongest signal strength. As the tracking gets worse, as it gets closer, it'll go ahead and switch back, as we saw in the initial settings when the aircraft was underneath it. It'll go ahead and use that omni-directional that'll pick up a stronger signal. So that's my antenna tracker. Seems fairly simple, straightforward, and with a power panel you can read out what the current location of the aircraft is, and I believe that if you crash or something, it'll just maintain that last remember settings, so you got a place to go look for a downed aircraft. And if I had my druthers, I'd like to have GPS on the power panel here, or I mean on the ground station. Sure, it'd be nice to have a compass built into that, so you wouldn't do the little. I could set home position on the aircraft, oh, say way out there, so I could do a return to home and land in a safe location, which would not be on top of the ground base. Anyhow, that's it. Antenna tracking.
Throttle cut, normal mode. Self-level on. Throttle cut, hold mode.